With over 250 million cars and trucks on the roads in the United States, and each typical passenger vehicle emitting 4.7 metric tons of CO2 per year, the U.S. has the opportunity to reduce greenhouse gas emissions through alternative forms of fuel, including electricity. A vehicle that is entirely powered by electricity, in comparison to gasoline-powered cars, emits no tailpipe emissions, but is rather an elsewhere emission vehicle, meaning that there are still certain greenhouse gas emissions associated with the car, like during production. However, this drastic reduction in tailpipe carbon dioxide is an appealing reason to consider the benefits and consequences of switching from conventional gas and diesel vehicles to the electric car. Electric vehicles that are powered by renewable sources like wind or solar are especially attractive. An electric vehicle is similar to a gasoline-powered car, but has a battery instead of a fuel tank that is charged from an external source of electricity. Instead of an internal combustion engine, it has an electric motor. The motor can also serve as a source of charge for the battery by recapturing energy from braking. Electric vehicles require less maintenance than gasoline-powered cars. Brake pads, for example, last longer in electric vehicles because of the energy captured from braking that can be stored in the car's battery. It costs only $1 for today's all-electric vehicles to travel the same distance as a similar-sized gasoline car would on a gallon of fuel, which is currently $2.65 a gallon. Electric vehicles are not 100% environmentally friendly, nor are they necessarily economically feasible. Reduction in greenhouse gas emissions, sustainability, and economic implications of switching from gas-powered to electric cars are important consequences to consider as we drive toward our future.
As advertised, electric vehicles offer great potential to reduce greenhouse gas emissions. However, companies may exaggerate this potential reduction. To avoid this exaggeration, we must consider a life cycle assessment of electric cars, including their production phase and its associated externalities. These externalities include increases in human and water toxicity resulting from the mining of necessary rare earth metals in countries with significantly fewer environmental regulations than the U.S. Overall, EV production impacts are more harmful to the environment than conventional vehicles. According to Hawkins et al., when using a life cycle assessment of electric vehicles, the reduction in emissions for electric cars versus gasoline is 9 to 14% for vehicles driven at least 60,000 miles, and up to 24% for vehicles driven at least 90,000 miles. As such, investing in an electric vehicle pays off more the longer the car is on the road. Fortunately, the average age of cars on the road has steadily risen over the last 2 decades, from about 8 years in '95 to 11 years old today. People now drive, on average, more than 13,000 miles a year over 11 years. As a result, cars today are lasting at least 140,000 miles. Accordingly, an electric car could reduce emissions by more than 30% compared to gasoline vehicles. Since the amount of cars on the road is predicted to more than double by 2050, a 30% decrease in emissions is extremely important to protecting the future of our environment.
Vehicle emissions are typically divided into 2 general categories: air pollutants, which contribute to smog, haze, and health problems, and greenhouse gases, such as carbon dioxide and methane. Both types can be evaluated on a direct basis method, as well as a well-to-wheel basis method. A direct basis method measures the emissions that are produced through the tailpipe, as well as through evaporation from the vehicle's fuel system and during the fueling process. A well-to-wheel basis method, on the other hand, includes all emissions related to fuel production, processing, distribution, and use. For electric cars, this is primarily comprised of emissions from electric power plants, as well as the emissions associated with the extraction, processing, and distribution of the primary energy. Unlike conventional vehicles, which contain internal combustion engines that produce exhaust and evaporative emissions, electric cars emit zero tailpipe pollutants. However, while the long-term potential for electric cars to reduce greenhouse gas emissions is great, there is still a considerable difference around the country in the amount of greenhouse gas that results from charging the battery packs of the cars. In areas such as California, for instance, where the electric utility relies on natural gas, nuclear, hydroelectric, or renewable sources to power its generators, carbon footprints are relatively low. However, in locations such as Denver, Colorado, continue to burn high percentages of coal to produce electricity. Unfortunately, regional mixes of coal-dependent utilities like these diminish the electric car's potential benefit to combat global warming.
Electric cars are very expensive, with cars such as Tesla costing up to $100,000. Considering that the median household income in the US was $52,250 in 2013, it seems implausible that electric cars could be used on a scale that encourages environmental sustainability. An increase in the supply of electric cars would drastically decrease the price of the cars. And we may see this happen in the near future, as Tesla recently released the patent for its battery, thus encouraging other car producers to develop their own electric vehicles. The question of demand for electric vehicles is more challenging, especially because if you own an electric car, you also have to own an electricity sapping charging station, or at least live in close proximity to a public one. This is where the government can step in. They can raise taxes on fuel-powered vehicles or provide tax cuts for people who drive electric cars. Alternative solutions also include programs that ensure electric car owners do not have to pay, or can pay a fraction of, the cost of electricity used specifically to charge their cars for a certain length of time. Perhaps until money saved from this cost cut is equivalent to the cost of the car or the cost of the gas they would have otherwise pumped in that time period.
In the next generation, electric vehicles are a viable possibility as electricity becomes a greater part of our economy. Especially as options for renewable energy for electricity continue to grow and develop, the electric car will become that much more essential. Today, we can make small changes in our driving behavior to have a meaningful impact on the environment.